Welcome friends and welcome to my series of video lectures on design of steel structures. The topic of this video is design of a welded connection for a truss joint. For best video quality, watch on laptop or desktop with resolution set to 1080p, that is HD. The expected learning outcome from this video is design a welded connection for a lap joint in a truss. The key terms used in the video are fillet joint, shop weld, heel and toe of an angle section, maximum and minimum weld size, strength of weld, throat thickness, weld length. Friends, we have got our best friend Smarty for some smart study tips. First, write down your own notes while watching the video. Pause or rewind the video whenever required. And do solve the formative and summative assessment quizzes in the video. In this video lecture, we are going to study a complete numerical problem on design of a welded connection for a lap joint in a truss. Statement of the problem is design a welded lap joint to connect an angle ISA 100 by 75 by 10 to 12 mm thick gusset plate or 12 mm thick plate using shop welds to transfer an ultimate pull of 285 kN by providing A. Fillet weld along length at heel and toe of the angle, and B. Fillet welds at heel and toe and a transverse weld along the connected leg of the angle. So this is a single problem containing two problems A and B. This is the diagram of the problem. Here we will understand the details of the diagram. We see this plate in green and we see this angle section. This is single angle section. Since it is 175 10, this is an unsymmetrical angle section. One leg is 100 mm in length, the other is 75 in length. 10 mm is the thickness of the angles and the legs of the angles. So this is a plate connected to an angle. Now you can see this view. This is a cut view of the cross-sectional view of connection. Here we see this plate in vertical position, the green one, and this is the angle. It is seen in cross-section. So you see this longer leg as 100 mm. You see this 75 mm leg. Now this longer leg which is connected here, this is called as connected leg, whereas this 75 mm leg which is projecting out, which is not directly connected to the plate, this leg is called as unconnected leg or outstanding leg. So whenever there is an angle connected to a plate, one leg will be connected to the plate and the other leg will have to outstand. So in this case, usually we find that the longer legs are connected in order to have a better connection, and the shorter legs are kept outstanding. So now how to connect this angle to this plate through this longer leg connected? So for that we are going to use welds in this problem. So this is weld 1, this blue line, thick line indicates weld 1, this is weld 2. So we find that we are connecting this by two legs, two welds. Now for that we have to refer to the statement of the problem. In part A, they are saying by providing fillet weld along length at, now along length, so this is the length of the angle. So along the length of the angle means you have to provide the welds parallel to this length. Then at heel and at toe of the angle. So they are telling that you should provide along the length at heel and as well as at toe of the angle. Now this edge, this point is called as heel of the angle, heel, and this is called as the toe of the angle. So this connecting point to these two legs, this is called as heel, and this is the toe of the angle. So at heel and at toe means this complete length is heel and this complete length is toe. So this is along the heel and this is along the toe. So we are getting these two welds like this. Now here we see that this line is seen, which is the thickness line, 100 by 75 by 10 mm thickness. This 10 mm thickness is this line, you can see extended here. So this is the diagram, understanding of the diagram. Now we will understand the forces and the weld lengths and all these details in a short detail. So we see that this force Tu of 285 kilonewton, which is already given as ultimate pull, it is acting on the connection. So pull means tensile force. So these arrows of the forces Tu are away from each other. They are tensile forces. Now look at their line of action. This force Tu is not acting at the center of this leg, that is at 50 mm from the bottom. It is acting lower, at a line lower than that. So it means that this is an unsymmetrical section, and that is why its centroidal x-axis of that angle section is not at its geometrical center. So it is lower than the geometrical center. This distance Cxx indicates the distance of the centroidal axis from the bottom of the section. So the force is acting, Tu force is acting along the centroidal axis of the section, not at the geometrical center of the section. Now every weld, this weld and this weld, weld 1, weld 2, will produce a force of resistance. So P1 is the force of resistance of weld 1 and P2 is force of resistance developed by weld 2. You will see that the distance of this weld 1 or the length of weld 1 is greater than weld 2, length of weld 2. So these are of unequal lengths. Now why are they of unequal lengths? This is the reason we will see now. Now the force resisted by a weld P1 will be directly proportional to the length of this weld. Whatever length is provided, the force P1 will be proportional to length of weld. So this clearly means that this length L1 is greater and L2 is smaller, so P1 must be greater than P2. Now why they are greater or less than each other, why they are not equal? The reason is here. The reason is that the resultant of weld forces P1 and P2 should coincide with the load line Tu to avoid eccentricity of connection. Now let us understand this. So the forces P1 and P2, they should be such that their resultant should pass through this Tu line. Now we see that this Tu line is not at exact center of P1 and P2, geometrical center, because of unsymmetry of the angle section. So that is why we get this P1 greater than P2. So P1 and P2, their magnitudes, which means the lengths of the welds, finally they are to be so adjusted that the resultant of P1 and P2 will pass through the centroidal axis, that is along which the load Tu is acting. Now why is it to be done? This is to avoid eccentricity of connection. This connection will otherwise become eccentric. That means the applied load will 285 will be acting at one point along one line, whereas the line of action of the resultant of P1 and P2, that is the resultant resistance, they will not coincide and they will create a moment and they will try to rotate the connection, and the connection or the welds will be subjected to bending also. So that will become another and complicated problem. To avoid that complication, we are having this connection as a axial connection, and for that we are having P1 greater than P2, that is L1 greater than L2. Now we proceed to solve the problem. So solution: We start with part A as we have seen in this diagram. Fillet weld along the length only at heel and toe of the angle section. Now there are two steps. Procedure of solving the problem is short and simple. What we have to do is, it's a very simple thing. What we have to do is, we want to finally find out the lengths of the welds. That's all. What is this L1? What is this L2? For that, in step 1, we have to calculate how much force a weld will resist for a unit length. For example, weld strength per mm of weld length. So 1 mm of this length will resist how much force? That is called as weld strength. So this is what we have to calculate in this step 1. Weld strength per mm weld length. Before we proceed for that, we have to refer to some IS 800-2000 provisions for welded connections which we have seen in earlier video. We'll be now only applying them. For that, we have to see maximum weld size. The IS code has imposed two limits, one from the maximum size of weld and one on the minimum size of weld. So we have to decide that size. What is the size of the weld? If you look here, it is the thickness of this weld which you see blue line. That is the size of the weld. So maximum weld size for rounded corner, you will see here that the corner of an angle section is rounded and you are putting a weld above that. So for rounded corners, maximum weld size is 3/4 the thickness of thinner plate. That is 3/4 into 10. So thinner plate is 10. Thinner plate means out of this plate is of 12 mm thickness and the angle is of 10 mm thickness. So thinner of the two is 10 mm. So you get this is as 3/4 of 10, that is 7.5 mm. So your weld size should be maximum 7.5 mm. Now minimum weld size. There is a restriction on minimum weld size also. So you must provide at least 5 mm for this particular case. Now that is, this value is obtained from table 21 of IS 800-2007 which we have seen in the earlier video. So this table will tell us that for an angle section or for a connection having the thickest plate of 12 mm, you will require minimum weld size as 5 mm. So this minimum weld size, this table 21 is based on the thickness of the thicker plate, and based on that you have to decide the minimum weld size. So we have to provide a weld between 5 mm and 7.5 mm. So we will provide the weld size of 6 mm. So provide weld size 6 mm. Now once we provide weld size of 6 mm, we know that the throat thickness of the weld TH is 0.707 into 6, that is 4.24 mm. So the throat thickness, as we have seen in the diagram here, this is the throat thickness you can see in this diagram. So this is given by, this throat thickness is 4.24 mm. So strength of weld per unit length, FWD, which we want to find out from this step. The formula is given in the IS code. The formula is 0.462 FU into TTH. TTH is the throat thickness. So this is equal to, this finally amounts to 0.462 into 410. 410 is the thickness, the ultimate strength of the weld. So this is 410 into 4.24, that is the throat thickness. So this works out to be 0.8 kilonewton per mm. So the conclusion of this step is that 1 mm length of the weld will resist a force of 0.8 kilonewton. So if you provide 1 mm weld, then it will generate a force of resistance P1 of say 0.8 kilonewton. So that was the conclusion of this step 1. We will now continue with step 2. Step 2 is design of welded connection. As we have seen, calculation of weld lengths L1 and L2. That is the meaning of design of welded connection. So we will proceed. Provide two welds of lengths L1 and L2 to resist forces P1 and P2 respectively, so that Tu is equal to P1 plus P2, that is equal to 285 kilonewton. We have already discussed this point a bit, that we want to generate resisting forces P1 and P2 through the welds, so that they balance this force of Tu 285 kilonewton. So this Tu is 285 kilonewton given, so we have to generate a total force of P1 plus P2 equal to 285, so that this applied load will be properly transferred through the welds. So it's a very simple arithmetic. So earlier we have also seen that these P1 and P2 cannot be equal. This cannot be 285 upon 2, half, because they cannot be equal, because this angle section is unsymmetrical. That is why these lengths L1 and L2 are supposed to be different. L1 is supposed to be greater than L2, that is P1 is supposed to be greater than P2. And the condition is that, as we have seen in the earlier slide, the condition is that the resultant of P1 and P2 should coincide, should pass through this line. That is the line, centroidal axis line of the section. Now that means we will have to calculate P1 and P2 according to that condition. Now how to calculate according to that condition? For that, the simple thing is, from you will recollect from applied mechanics, that we will calculate moments of all the forces about any point. We can consider here P2, force P2. So just understand this equation. To calculate P1 and P2, taking moments of all forces about say P2, we are saying say P2 means you could have taken P1 also, you could have taken Tu also, you could have taken any point. So we are taking P2. So just understand this equation. This is sigma, means algebraic sum of moments. This is going to be equal to 0, sigma m equal to 0. This is just equilibrium equation, third equilibrium equation. So sigma m equal to 0 about P1. Remember that we are doing all these, taking all these moments about P1, sorry P2. Now what are the forces acting? This is P2, this is P1, and this is Tu. Remember that this second Tu will not come in picture now. We are talking about this Tu and these two forces. Okay. Now if we are talking about this Tu, then the two opposite direction forces would come into picture. That is, we are not talking about. So this Tu and these two forces, these are the three forces we are talking about, and their moments about the force P2 itself will be equal to 0. This is how we are applying the condition of equilibrium to this connection. So let us take the moments. Just look here. So let us take the moment of force Tu. For example, force Tu. This force Tu from P2. So what is the distance of this force P2 from this? You know what is a moment? I am just going in the past little bit to refresh your idea of taking moments. I know this is a bit of troublesome thing for most of the students. That's why I'm going a bit in detail of the concept of moment. So a moment of a force, that is moment of force Tu about P2 will be the force Tu, magnitude of Tu, into the distance of Tu from force P2. So distance, perpendicular distance between Tu and P2, that you have to take. So Tu into this perpendicular distance. What is this perpendicular distance? You will see that in this diagram, in this section, you see that this is total is 100, out of which this is Cxx. Okay, this is CXX, centroidal distance of x-axis from this leg. So this CXX, 100 minus CXX will be this distance between TU and P2. So multiply this by TU into 100 minus CXX. Now this entire moment, there is another parameter about moment, that it can be either clockwise or anti-clockwise. So take the moment, consider this moment of TU, that's this TU. Of course we are not talking about this TU, we are talking about this TU. So moment of this TU about P2, you will see that it will be a rotation of this type. That means it will be anti-clockwise. So anti-clockwise moments are treated as negative, minus. So we have assigned this minus sign. This fact should be understood very clearly, because this is resulting in final answer, numerical answer. So it is a matter of accuracy of numerical calculation. So this is how we calculate TU into 100 minus the XX, and the sign is minus. So moment of TU about P2 is TU into 100 minus the XX, and the sign is minus, because this TU will try to rotate about this force P2 in anti-clockwise sense. So this was the moment of one force, this TU force. Now the second force is P1. We know that we are considering all forces. So first force was TU. We will now consider P1 force. Look at P1. This is P1. Its moment about P2 will be its magnitude P1. This is P1 into 100. What is the distance of P1 from P2? We are taking moment of P1 about P2. So distance between P1 and P2, this is nothing but 100. This is 100 mm. We are assuming that these weld forces P1 and P2, they are acting at the edge of the angle, at the edges of the angle, at heel as well as at toe. They are acting at the edges of the angle. So these distances apply. So we get distance between P1 and P2 as 100. So the moment of P1 about P2 will be P1 into 100. Now the only question is of the sign. Why it is plus, why it's not minus? So look at P1, direction of P1. It has a it's a sense of rotation with this arrow tip. It will rotate about this P2 in clockwise sense. You can see this sense. This is the clockwise sense. So this moment will be, moment of P1 about P2 will be clockwise. So we get P1 into 100. Now the third force is P2. We have got three forces, P1, P2 and TU. We have taken moment of TU, we have taken moment of P1. Now we have to take moment of P2 about P2 itself. So moment of a force about itself will be 0. And that is why this third term will not appear here. We are not written that 0 at all. That's no matter writing it. So we get this equation. So sigma m is this equation, and that is equal to 0. So I hope you have understood this equation clearly. You can pause the video and rewind video if you want to get it clear again. Now this is a matter of calculation now. In this calculation, TU is given as 285, then P1 is not known, it is to be found out by this equation, but CXX is required. Now what is CXX? CXX is a sectional property of this angle. You can see what is the distance CXX. It is the distance of the centroidal axis of the angle from the bottom. So this distance is CXX. Where from will you get the value of this? Or that you will have to refer to steel table. So from steel table you get CXX equal to 31.9 mm. We have already got a video, and in that video we have already explained what is the meaning of steel table and what are the standard steel sections and what is CXX, CYY and how to calculate all that. So you will get this from the steel table. So this is 31.9. In some cases in the problem they may give this data in the statement of the problem itself. In that case, you don't have to refer to steel table, but if it is not given, the best and final way is to go to the steel table and find out the value of CXX for ISA 175-10. So you get this 31.9 mm. So you get to put this here, and like this you get this equation, and solving this equation you get P1 equal to 194.1 kilonewton. This is what you get. So looking back at this problem, we see that to resist this 285, P1 should be equal to 194.1. So P2 should be equal to the remaining force, that is 285 minus P1. So we cite here, therefore P2 equal to TU minus P1, that is 90.9 kilonewton. So this P1 and P2, they are now going to be 194.1 and 90.9. So you got their values of the forces. Now from step 1, you have already calculated how much force is resisted by 1 mm of weld length. 1 mm of weld length will resist 0.8 kilonewton. This is the outcome of the step 1. So we will apply that value here. That is why we will, how much length of this weld one we will require? L1. If 1 mm is resisting 0.8 kilonewton, how much length will you require to resist 194.1? So this is L1 equal to P1 upon FWD, that is this, and this amounts to 243 mm. It tells us that this weld 1 should be L1 equal to 243 mm. We know that it is not possible to provide 243 mm on the site, and that is why it is to be rounded off to 250 mm, nearest integer of multiple of 10. So this is 250 mm. Similarly for L2, you have to resist only 90.9. So 90.9 upon 0.8, you will get 114 mm, rounded off to 120 mm. So you get weld 1 as L1, that is 250 mm, and weld 2 as L2 length, that is 120 mm, with P2 equal to 90.9 and P1 equal to 194.9. So this is how this welded connection is now completely designed. The forces P1 and P2 are calculated in such a way by taking moments that their resultant will pass through this TU, or the centroidal axis of the angle, and therefore you will not get any moments or any eccentricity for the connection. So that was part A of the problem. Now we will see part B of the problem. So friends, let us consider part B of that problem. The problem is the same, 285 TU is there, all the dimensions, everything is the same. But in part B, we have to provide fillet weld along the length and heel of the angle section. Plus, in addition to that, we have to provide a transverse weld also, the third weld. So in this problem, we are supposed to provide 3 welds. The procedure is going to be the same. The logic is also going to be the same. Only one force is added. So let us see how we will solve this problem. The step 1 is the same. Required, so the strength of the weld, that is FWD. Okay, the force resisted by weld. This was from step 1, already there. Now we will proceed for step 2. For step 1 does not require any revision. Step 2 is design of welded connection. In this now we have to calculate weld lengths L1, L2 and L3. There are 3 welds now. So let us see where is the third weld. You will see this L1, L2 are already there, but this third weld, vertical weld, has also come. Why it is called transverse weld? Because the meaning of the word transverse is perpendicular to the length. Longitudinal means along the length. Transverse means perpendicular to length. So this weld is perpendicular to the length of the angle. So this is called transverse weld. Now you will see here that provide three welds of lengths L1, L2 and L3 to develop resisting forces P1, P2 and P3 respectively, so that TU is now equal to P1 plus P2 plus P3. So this TU is, this is on one side, these are the three resisting forces. Now total length of the weld. Let us see for 285 what is the requirement of total length of weld. The distribution as L1, L2, L3 will be done later. First of all, let us find out what will be the total length of the weld required. So it will be, total length of the weld required will be L, say L, equal to TU upon FWD. TU is total force upon the weld strength. So this amounts to 285 upon 0.8 kilonewton per mm. This is 357 mm. So we require 357 mm as the total length of the weld. Now out of these three, L1, L2, L3, we know that this transverse weld, that is weld 3, its length is fixed because it is along the entire leg. So this is going to be 100 mm. We don't have to do any calculation. So length L3 is equal to length of connected leg, that is 100 mm, with P3 equal to FWD L3. So how much force will this weld resist? That is also fixed. Since its length is fixed, its force P3 is also fixed. So this will give us P3 equal to FWD into 3, that is 0.8 into 100, that is 80 kilonewton. So this P3 is known and this length is known. Now the remaining force 100 mm, 80 mm is to be subtracted. So whatever remains, that force is to be resisted by P1 and P2. Now here we see, now L1 plus L2 equal to L minus L3. So total 257 mm length requires to be provided through P1 and P2, or L1 and L2. Now to calculate the values of P1 and P2, P3 is already known, P1 and P2, we take moments of all forces about P2 as already done in part A. But here we have to see that we have got three forces, P1, P2, P3, and the fourth force is TU. So we have to take moments sigma m equal to 0. See, these moments are to be taken for all the four forces now, not three. So just one force has got added, that is the thing. So let us go ahead. Let us take the moment of TU with, or this TU, force moment of this TU about force P2. So moment of TU about P2, this is the same as we did in the last step, in the first step A. So this is TU into brackets 100 minus CXX, and it is going to be minus because it is anti-clockwise about P2. So this is that this term remains the same. Second is P1 into 100, moment of force P1 about P2. This is going to be P2 into distance is 100, and it is going to be clockwise about P2. Now so this was the second thing that we got. Now we will require a third term, that is P3. Look here, this is force P3, moment of P3 about P2. What will be the moment of P3 about P2? So it will be magnitude of P3. So we write P3 here. And what will be the distance between P3 and P2? This P3, now here we have to note one important point, that this P3 is, this force is acting at the center of the weld. Okay, this force is acting at the center of the weld, and that is why this P3 is acting at 50 mm, half of 100, 50 mm from P2. So we will get P3 into 100 upon 2, this is 50. So this total will be 0, and this P3 you will see this is also having clockwise sense of rotation. So we will get all this. Then moment of P2 about P2 is 0, so that is not written here. So sigma m means moments of all the four forces about P2, so they are taken, and we get, on calculation of all these things, we get finally P1 equal to 154.1 kilonewton. So this is the value of P1 we get. So here P1 has become 154.1. Now therefore P2 will be, we know P3 now, we know P1 also. So P2 will be 285 minus P1 minus P3. So we will TU minus P1 minus P3. So we get this answer as 50.09. 50.09. You can solve this problem on paper and you can do the calculations on your own also. So in this way we get P1, P2, P3, all the forces calculated. Now the last thing is to calculate the lengths of welds required to generate these forces. So out of the three, L3 is already known. L3, weld 3, L3, it is already 100 mm. Now L1 and L2 are to be calculated. So L1 will be P1 upon FWD. So this will be P1 154.1 upon 0.8. So this gives us 193 mm. So this is rounded off to 200 mm. Similarly, L2 is P2 upon FWD 50.09 upon 0.8. So this gives us 64 mm, 64 mm, which is rounded off to 70. So finally we get the three weld lengths. So design of welded connection, the meaning was calculation of weld lengths L1, L2 and L3. So we get the weld lengths as L1 equal to 200 mm provided here. L2 is 70 mm and this is 100 mm. If you compare these values with the part A of values, you will find that both L1 and L2 were greater than these values. Because this third has come, this has reduced L1 and L2 also, because weld 3 had shared a force P3, and that is why it has helped the weld 1 and weld 2 to reduce their lengths. So if you have got three welds, all the three welds will be of lesser length as compared to the part A. So here you see this is weld 2, this is weld 1. Now you can obviously understand that in this particular view it is not possible to see this transverse weld. So weld 3 will not be visible in this view. It will not be visible in this view, but it will be visible in this view. So this will also give you a feel that, or give you an understanding that why we require two views of any drawing. One view sometimes does not give us some information, so the second view can give it. So that is why we usually draw two views of any drawing. So this was part B of the problem, and here we complete the solution of the entire problem. Friends, before we close, we have got a formative evaluation self-test. The question for the self-test is, two plates of size 180 mm and 8 mm are connected by a lap joint using shop welding. Plates are of Fe410 grade. Design fillet welds for ultimate tensile force of 400 kilonewton. This is application level problem. So do solve this problem by revising whatever we studied right now in the earlier problem, and after you have completed the problem, we can proceed for the next slide. So friends, we have come to the end of the lecture. Let us sum up. So we were solving design of a welded connection which was a lap joint in a truss member. So the expected learning outcome from this video was design of a welded connection for a lap joint in a truss. We were using the keywords fillet joint, shop weld, heel and toe of angle section, maximum and minimum weld size, strength of weld, throat thickness, weld length. I hope you have understood the problem and you will be able to make use of the key terms in order to consolidate the content of the video. If you have got any doubts, contact your teacher and get solved your doubts and queries. There is a summative assessment quiz in the form of Google quiz which will be available to you for the teacher. So do attempt that online quiz to confirm your outcome. So with that, we come to the conclusion. Thanks for watching the video and goodbye till we meet in the next video.